I'm here on page 59. So make sure that you get on page 59 of your book. Pause it if you need a minute. And lesson 6 is called equivalent ratios. Again, our learning objective is I can determine if a pair of ratios is equivalent. So we're going to have two different ratios or rates, and we're going to say if the ratios and rates are equivalent to each other or not. There are two ways we're going to learn about to do this. One, we're going to try to simplify and use unit rates. And if we can't do that, then we're going to try to see if the two fractions are equivalent. Now, just our first example is going to be looking at this little table right here. It's talking about photography. It says Andrea spent $2 to make 10 prints from a photo booth. Later, she spent $6 to make 30 prints. So, express the relationship between the number of prints she made and the total cost for each situation as a rate in fraction form. So this is just turning the rate into a fraction. So she had 10 prints for $2. And then later she got 30 prints for $6. And it says compare the relationship between the numerators of each rate in exercise 1. Compare the relationship between the denominators of these rates. So look, the numerator in the second rate, right here, 30 versus 10, well, 30 is 3 times more than 10. The denominator, 6, is also 3 times more than 2. So that's one way that you can compare them. Or you could look at unit rates. So what is the unit rate for 10 prints? Remember, for a unit rate, you divide both the numerator and the denominator by that denominator. So if you have 10 divided by 2 and 2 divided by 2, it's going to give you 5 prints for $1. So that unit rate would be 5 prints per $1. The unit rate here, you divide both by 60. That's what the denominator is. So you're going to get 5 prints for $1. So that's the same thing. Interesting. 5 prints for $1. So look at this here. Technically, you could say 10 prints for $2 is equivalent to 30 prints for $6 because when you simplify it to the unit rate, they're both 5 prints for $1. So that's the kind of stuff we're going to be looking at right here. Let's turn to page 60. So again, we're trying to figure out how do we know if two ratios are equivalent. And the easiest way to do this is to simplify and use unit rates. So if your numbers are numbers that will easily let you get to a unit rate, we'll always try using unit rates first. It says there are different ways to determine if two ratios or rates are equivalent. One way is by examining unit rates. By comparing quantities as rates in simplest form, you can determine if the relationship between the two quantities stays the same. So this is the example from the front. She printed 10 prints for $2. She had 30 prints for $6. We found the unit rate of 10 to 2 by dividing by the denominator. So we found that that was 5 prints for $1. And when she bought 30 prints for $6, the unit rate there, dividing by 6, the denominator, is 5 prints for $1. Since the rates have the same unit rate, they are equivalent fractions. So this is going to be the big question you ask yourself. Do they have the same unit rate? If two rates or ratios have the same unit rate, then they are equivalent. If they don't, then they're not equivalent. So we're going to practice with different rates to see if they're equivalent by finding the unit rate. Let's look at the first example. Determine if each pair of rates is equivalent. Explain your reasoning. So 20 miles in 5 hours, 45 miles in 9 hours. Write each rate as a fraction, then find its unit rate. So this is the procedure that we're following. Write it as a fraction, then find the unit rate. So 20 to 5, 20 miles in 5 hours. That's the fraction for that one. The fraction for this one, 45 miles in 9 hours. 45 miles in 9 hours. find the unit rate. So for this one, divide by 5, the numerator and denominator. 20 divided by 5 is 4. 5 divided by 5 is 1. With a 1 in the denominator, we have a unit rate of 4 miles per hour. To find the unit rate here, divide both the denominator and numerator by 9. So you have 5 miles in 1 hour. So this 1 at the bottom means it's a unit rate. Now look, this had 4 miles an hour. This had 5 miles an hour. They're not equivalent. 4 and 5 are not equal. Since the rates do not have the same unit rate, they are not equivalent. Let's look at example 2. 3 t-shirts for $21. Write that first. We have to write that as a fraction. So $21 for 3 t-shirts. 5 t-shirts for $35. $35 for 5 t-shirts. Now, do you guys remember when we were doing the unit price? You put the price on top. So the price is in the numerator. That's what this example 2 is showing, that when you set up the fraction, you put the price in the numerator. So even though it's 3 to 21, we put the money in the numerator so we can get a 1 in the denominator. So for this first one here, to get the unit price, we divide numerator and denominator by 3. You get $7 for 1 t-shirt. In here, we need to divide by 5. So we have $7 for 1 t-shirt. And look at this, $7 per t-shirt, $7 per t-shirt. Cool, they have the same unit rate, so they are equivalent. This would be a yes. All right, now we're going to do a couple examples here. So we're actually going to try this. I'm going to show my work for A right over here. We have 36 t-shirts in 3 boxes, 60 t-shirts in 6 boxes. The first thing we need to do is write these out as fractions. So 36 t-shirts in 3 boxes. I'm going to write that right here. 36 t-shirts, 3 boxes. All right, let's write this one out. 60 t-shirts in 6 boxes. So we have 60 t-shirts, 6 boxes. Okay, now do this with me. The next step after we write them out as fractions is to divide and find the unit rate. So we need to divide this one, numerator and denominator, by 3. That's going to give us the unit rate. 36 divided by 3, that's the 12. 12 times 3 is 36. So that's going to be 12 t-shirts for 1 box. And with this one, we need to divide both numerator and denominator by 6 to find the unit rate. All right, so 60 divided by 6 is 10 t-shirts per 1 box. So look at this. 12 t-shirts per box, 10 t-shirts per box. These unit rates are not equivalent. No good. So this would be a no. This would be a no because these unit rates are not equal. All right, now let's do example B. So we have 42 flowers in 7 vases, 54 flowers in 9 vases. Let's see if they're equivalent. I'm going to show my work right here for this one. So let's write it as a fraction. 42 flowers, 7 vases. This one, 54 flowers in 9 vases. All right, now let's find the unit rate. So draw a line there. For this first one, we have to divide both numerator and denominator by 7. Okay, and then so 42 divided by 7 is going to be 6 flowers for 1 vase. And then down here we need to divide both numerator and denominator by 9. So 54 divided by 9, that's going to be 6 flowers in 1 vase. So look at this. The unit rate is equivalent. They both are 64 flowers per 1 vase. So this is going to be a yes. They are equivalent. Yes. Unit rates are equal. All right. Now, page 61. We're still able to work with unit rates. These examples right here are the same thing we just did, except over here, it wasn't like a story problem. So they just gave you these different rates and you had to put them in a fraction form. This is going to be like story problem form. So check out this first story problem. Felisa read the first 60 pages of a book in 3 days. She read the last 90 pages in 6 days. Are these reading rates equivalent? Explain your reasoning. So you set it up as fractions. 60 pages in 3 days for this first part. 90 pages in 6 days for the second part. You find the unit rate. So this one you divide by 3, 20 pages per day. This you divide by 6, 15 pages per day. So they do not have the same unit rate. Those rates are not equivalent. All right, let's try these story problems right here. So C, we're looking at Marcia. Marcia made 10 bracelets for 5 friends. Jen made 12 bracelets for 4 friends. Are these rates equivalent? Explain your reasoning. So let's find the unit rates. Marcia, here's Marcia. She had 10 bracelets for 5 friends. That's Marcia. Here's Jen. Jen had 12 bracelets. 12 bracelets for 4 friends. 12 bracelets, 4 friends. Let's find the unit rate. So for this one, what do we divide by? The denominator's 5. 10 divided by 5. 2 bracelets per friend. For this one, the denominator's 4. 12 divided by 4. So she made 3 bracelets per friend. These are not equivalent. Jen made 1 more bracelet per friend than Marcia. So not equivalent. The unit rates are different. Okay, let's check out the next story problem right here on page 61. This is D. Club A raised $168 by washing 42 cars. Club B raised $152 by washing 38 cars. Are these fundraising rates equivalent? Explain your reason. So let's talk about Club A. Club A, we got to set up the fraction. $168 for 42 cars. Notice I put the money in the numerator because we're finding a unit price here. All right, Club B. Club B raised $152 for 38 cars. Okay, now let's find the unit price. So we need to divide the numerator and denominator by 42 because that's going to give us a 1 in the denominator. Now you might need to use your calculator for this. When I calculated it, 168 divided by 42 is $4 per 1 car. And then we need to divide both numerator and denominator by 38 so we can get a 1 for our unit price, 1 car. And using my calculator, 152 divided by 38 is $4 for 1 car. So are these equivalent? The unit rates are both $4 per car. So yes, unit rates are equal. Okay, so ladies and gentlemen, that was the first part of this chapter. You can use unit rates to determine if ratios or rates are equivalent. The second part of the chapter, though, is for situations where you cannot easily get to a unit rate. In that case, we're going to do what's called use equivalent fractions. If a unit rate is not easily found, we're going to use equivalent fractions to decide whether the ratios or rates are equivalent. Let's take a look at an example. Determine if the pair of ratios or rates is equivalent and explain your reasoning. Three free throws made out of 7 attempts. By the way, that's a tongue twister. Try saying that. 3 free throws. Tricky. Okay, 3 free throws made out of 7 attempts. 9 free throws made out of 14 attempts. If you set this up right here, 3 free throws and 7 attempts. You can't divide numerator and denominator by 3 and get a unit rate. You can't easily get a unit rate for that. So we need to find it. Same with 9 and 14. You can't like divide both numerator and denominator by 9 and get an easy number. So we can't do the unit rate for these. So here's what we're going to do. We're going to start just like before. We always write each ratio as a fraction. I started that on the other page over here. Write each rate as a fraction. I'm starring it over here. Except this time we aren't finding a unit rate. We're going to do something else. Let's see if the two fractions are equivalent. We have 3 free throws and 7 attempts. There's a little question mark here. Does it equal 9 free throws and 4 attempts? Well, let's take a look. The numerator and the denominator are not multiplied by the same number. Look, 3 times 3 gets us 9. 7 times 3 doesn't get us 14. It's 7 times 2 that gets us 14. Since times 3 and times 2 are not equal, the fractions are not equivalent. If both of them could be multiplied by 3 or both multiplied by 2, then yes, it would be equivalent. So this one, not equivalent. Since the fractions are not equivalent, you can then say the ratios are not equivalent. So we're going to take a look at an example. Let's go to page 62. Here's the example here. Selena is comparing the cost of 2 packages. By the way, this is the story problem example. Selena is comparing the cost of 2 packages of DVDs. A package of 6 DVDs costs $90. A package of 3 DVDs costs $45. Are the rates equivalent? Explain your reasoning. Well, what's the first thing we do? We have to turn these rates into a fraction. So 6 DVDs for $90. And then 3 DVDs for $45. Now, are these equivalent? Let's see. 6 to 3. Well, you have to say 6 divided by 2 is 3. What about 90 to 45? Well, 90 divided by 2 is 45. Since they're both divided by 2, then yes, the fractions are equivalent. So since the fractions are equivalent, the ratios are equivalent. Let's take a look at this problem here. This is example E. All right, let's do this one together. Mrs. Jeffries has 12 girls out of 16 students on the student council. The Earth Day Committee has 4 girls out of 8 students. Are the ratios equivalent? Explain your reasoning. Well, what's the first thing we do? We turn these into fractions. All right, so this first one, Mrs. Jeffries, 12 girls out of 16 students. So we have 12 girls out of 16 students. All right, the other one is 4 girls out of 8 students. So we want to know, are these equivalent? So we have 4 girls out of 8 students. So now let's see. 12 to 4. 12 divided by what is 4? 12 divided by 3 is 4. What about 16 and 8? 16. It's not 16 divided by 3, is it? It's 16 divided by 2. Since this denominator is divided by 2 and the numerator is divided by 3, these two fractions are not equivalent. And if the fractions are not equivalent, then the ratios are not equivalent. So this would be a no. The fractions are not equivalent. All right. Now, taking everything we've learned, the 2 different ways to see if ratios are equivalent. If you can get it into a unit rate, use unit rates. If it's not you're not easily able to find a unit rate, we're going to use equivalent fractions. Let's try the guided practice. Now we're only going to look at number 2, 3, and 4 on page 62 for the guided practice. What I'd like you to do is try it on your own. So you'll be like pausing the video, trying number 2 on your own, and then playing it, see if you did it correctly, and fix it if you didn't do it correctly. Let's just look at number 2 first before you pause and do number 2. 270 calories in 3 servings, 450 calories in 5 servings. By the way, what do we always do first? We always put the ratio into what form for these? Fraction form. So 270 calories over 3, 450 over 5. These can easily, 270 can be divided by 3, 450 can be divided by 5. So you're going to be able to use unit rates for this one. So pause it, see if the unit rates are equivalent, and then play it and see if you got it correctly. All right, here is the work for number 2. So we turn it into fractions. 270 calories in 3 servings, and then 450 calories in 5 servings. Now let's find the unit rate for these. We need to divide the numerator and denominator for this first one by 3 right here, so we can get a 1 in the denominator. 1 serving. 270 divided by 3. Did you use a calculator? You might not have needed to, because 27 divided by 3 is 9, and you add that 0. 90 calories per serving. All right, what about dividing by 5? So we got to get 5 divided by 5. That gives us our 1 to make the unit rate, 1 in the denominator. 450 divided by 5. Look, 45 divided by 5. What does that get you? 9. Add the 0. 90 calories. So look, 90 calories per serving, 90 calories per serving. Yes, the unit rates are equivalent. So that's explain my reasoning. The unit rates are equivalent. All right, before you pause and do number 3, let's just look at it for a minute. If you have Micah doing 75 push-ups in 3 minutes, Eduardo doing 130 push-ups in 5 minutes, are the rates equivalent? Could you find a unit rate? Could you divide 75 by 3 easily? Yes, 3/25, 3/4 gives you 75 cents. Can you divide 130 by 5 easily? Yes. It ends with a 0, so 130 is definitely a multiple of 5. So you're going to want to use unit rates for this, just like in example 3. Go ahead, pause it, do it, play it, see how you did, fix it if you didn't do it correctly. Also remember, you can always raise your hand if you get stuck and you can't figure out how you did it incorrectly. The teacher can help you. All right, go ahead and pause. Okay, so let's do the work here. We have our first fraction we need to make, 75 push-ups in 3 minutes. I'm going to put that right here. 75 push-ups, 3 minutes. All right, our other fraction, Eduardo had 130 push-ups in 5 minutes. Now, to get the unit rate, we need a 1 in the denominator, so we can divide both numerator and denominator by 3. That gives us 1 minute. 75 divided by 3 is 25 push-ups per minute. Now, let's see, who's this other guy? Eduardo. Let's see what Eduardo does. We divide by 5 to get a 1 in the denominator, so we need to divide this by 5. 130 divided by 5, if you calculate that, is 26. So 26 push-ups in 1 minute. So are these equivalent? No. The unit rates, 25 and 26, are not equivalent. So no, unit rates are not equal. All right, and now we're looking at number 4. So look at number 4 really quick. A human adult takes about 16 breaths in 60 seconds. A puppy takes about 8 breaths in 15 seconds. Are these rates equivalent? If you set this up, 16 breaths in 60 seconds, you cannot easily divide 60 by 16. Same with 8 and 15. You can't easily divide 15 by 8. So we're not going to be able to use unit rates for this one. This is like example 4 and 5. we are going to have to see when we turn these rates into fractions if the fractions are equivalent. So I want you to try that just like we did in example 5. Do number 4, pause it, and then play it to check your work. All right, now go ahead. Okay, so here's how we set up number 4. We always turn the rate into a fraction. So the human adult, 16 breaths in 60 minutes. 16 breaths in 60 minutes. All right, let's compare that. Or I'm sorry, it's not 60 minutes, is it? It's 60 seconds. Let's compare that to 8 breaths in 15 seconds. Is that equivalent? 8 breaths in 15 seconds. All right, well, let's see if the fractions are equivalent. 16 divided by what is 8? 16 divided by 2 is 8. 60 divided by what is 15? Well, there are 2 15s and 30, 2 30s and 60, so that's divided by 4. This is divided by 2, this is divided by 4. Those are not equal. So since the fractions are not equivalent, the ratios or the rates are not. So this is no. Fractions are not equivalent. Okay, now the major steps you need to remember is first, always turn the rates into a fraction. Second, if you can easily get a unit rate, then calculate the unit rates and see if they're equal or not. If you can't easily get a unit rate, then compare the fractions. See if the fractions are equivalent or not this way. You are going to be trying this on page 63. So let's circle what we need to do for independent practice. This is going to be the homework, and you might have time to do it in class. For independent practice, we need you to do number 2. So you are determining if this is equivalent to this. Are these two rates equivalent? You're going to do number 3. You're going to determine if this rate is equivalent to this one. Number 5, so there's a story problem. Again, you've got a package with 8 pairs of socks for $12, 3 pairs of socks for $6. See if they're equivalent. And then the last one is number 7. This is another story problem. Kira took 30 minutes to do 6 problems. Heath took 8 problems in 40 minutes. Ooh. Don't be tricked on that one. Look, the way it's worded, this puts the minutes to problems. This puts problems to minutes. How many problems can she do per minute? So you're going to want to make sure you set up Kira with the problems in the numerator. 6 problems to 30 minutes. 6 problems per minute. So you can see if that's equal to Heath, who did 18 problems in 40 minutes. So you might want to write that in to make sure that you're setting this up correctly. All right, you got to be careful when you set up the fractions that you put the problems both on the numerator and the minutes both in the denominator. So you are going to do number 2, 3, 5, and 7. I know you can do it. Use your examples over here in the guided practice and the examples on the other page to help you out. All right, we are on page 63, lesson 6, equivalent ratios, and we are checking our homework, the independent practice. So what I want you to do is I want you to check each one, and if you got it wrong, I want you to fix it. If you can't figure out why you got it wrong, please raise your hand and get some extra help from the teacher. But if you got something wrong, make sure you fix your work. All right, let's look at number 2. We had the 2 rates turned into fractions. So 12 to 3, $12 for 3 books, $28 for 7 books. Now, I found the unit rate because 12 can be divided by 3 and 28 can be divided by 7. So we can get ones in the denominator. So I set this up to find the unit rate. 12 divided by 3 is 4. 28 divided by 7 is 4. The 2 unit rates are equal. So yes, the rates are equal because the unit rates are equal. For number 3, I also set this up to find the unit rate because I could divide 12 by 3 and I could divide 36 by 9. So I set it up with the price on top so I could get a 1 in the denominator. So $12 for 3 hours, $36 for 9 hours. 12 divided by 3 is $4 per 1 hour. 36 divided by 9, $4 per 1 hour. Since these unit rates are both equal, $4 per hour, then yes, the unit rates are equal, so the ratios or rates are equal too. All right, now let's look at the story problem ones. This is number 5. Jenny is comparing the cost of 2 packages of socks. One has 8 for $12, another has 3 for $6. So look, I can't do 12 divided by 8. I could do 6 divided by 3, but I can't do 12 divided by 8. So I'm going to set it up and see if the fractions are equivalent. 8 socks for $12, 3 socks for $6. 12 divided by 2 is 6. 8 divided by 2 is not 3. I don't even, 8 divided by something, it's going to be some different number. So these are not equivalent. These fractions are not equivalent. So the rates are not equivalent. So no, the fractions are not equivalent, so the rate is not equivalent. All right, number 7. Remember, we wanted to set up the fractions so you had problems per minute, problems per minute. So Kira had 6 problems for 30 minutes, and Heath had 18 problems in 40 minutes. Now, again, you can't really find the unit rate. You can't do 40 divided by 18. You could do 30 divided by 6, but you can't do 40 divided by 18. So I set it up to see if the fractions were equivalent. 6 times 3 is 18. 30 times 3 is not 40. So 3, it does not have times 3 in the numerator and the denominator. So this is no good. The fractions are not equivalent, so no, the rates are not equivalent. All right. Now, you have finished the independent practice. If you have any questions before going on to the next step, make sure you check in with the teacher. All right, after checking your homework for lesson 6, equivalent ratios, we are going to get our learning journal. And we're going to reflect on the 2 methods that we learned about. So just keep in mind, remember, the 2 methods were to see if 2 rates or ratios are equivalent. Find the unit rate if you can. If you can easily find a unit rate with division to get a 1 in the denominator, compare the unit rates. If you can't do that, then compare the fractions and see if the fractions are equivalent. When you turn the rates or ratios into a fraction, see if they're equivalent. Those were the 2 ways. We're going to be writing about these 2 ways in our reflection. So the reflection for lesson 6, I can determine if a pair of rates is equivalent is 1, 2, and 3 here. For number 1, what are the 2 ways to determine if rates are equivalent? To see if the blank are equal or if the blank are equal. So remember, this was one way and this was another way if you need to look back in your book. So when comparing 12 cans for $4 to 18 cans for $6, I would see if the rates are equivalent by finding and comparing what? And why would you choose that? So which method would you use and why? And then show your work and solve if they're equivalent or not. And then here, when comparing 16 cans for $5 to 32 cans for $10, I would see if the rates are equivalent by what method would be better for that one and why. Show your work and say if they're equivalent.